Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today we are going to learn about principle of IR spectroscopy on the introductions part. So this video will be beneficial for JAM, NET, GATE and MSc entrance examinations. So let us start with introductions and principle of IR spectroscopy. I will discuss about introductions of spectroscopy, introductions of IR spectrophotometry, principle of IR spectroscopy and molecular vibrations. What is spectroscopy? This is very important topic for chemistry students. Not only chemistry, but other branches of science also much interested in this field. So, method of seeing the unseeable means like atoms and molecules. Using electromagnetic radiations, commonly EMR, to obtain informations about atoms and molecules that are too small to see. So my friend, spectroscopy is an instrumentally added study of the interactions between matter, sample being analyzed, and energy, any portions of the electromagnetic spectrum. You can see EMR, analyzed, concentrated should be lower or concentration should be lower, and a spectrophotogram graph. So EMR, UV visible radiations, excitation of electrons, UV visible spectrum, IR radiations, vibration changes in electrons, IR spectrum, and many more spectroscopy techniques like NMR is also associated with EMR. So I will focus on IR spectroscopy. You know, energy of molecules is equal to electronic energy, vibrational energy, and rotational energy. IR spectroscopy is concerned with the study of absorptions of infrared radiations, which causes vibrational transition in the molecule. My friend, IR spectroscopy, also known as vibrational spectroscopy. IR spectra are mainly used in structure elucidations to determine the functional groups. I repeat, IR spectra are mainly used in structure elucidations to determine the functional groups. You can see the higher frequency, shorter wavelength, lower frequency, longer wavelength, opposite relationship. So, molecular effect, ionizations, electronic transitions, molecular vibrations, rotational motions, and nuclear spin transitions with different rays in gamma rays region, X-ray regions, vacuum UV visibles, near UV visibles, visibles, infrared, microwave, and radio wave. And this is the level of energy. So, my friend, IR regions 800 nanometer to 1 mm. There are different subdivisions also near IR, middle IR, and far IR with different range. You can see here. Most of the analytical applications are confined to the middle IR regions because absorptions of organic molecules are high in these regions, middle IR. Now, I will discuss about the principle of IR spectroscopy. Molecules are made up of atoms linked by chemical bonds. You know that. My friend, this is very common in chemistry. Molecules are made up of atoms linked by chemical bonds. The moment of atoms and the chemical bonds like spring and balls. You can see in this diagram. So, these characteristic vibrations are called natural frequency of vibration. Now, when energy in the form of infrared radiation is applied, then it causes the vibrations between the atoms of the molecules, and when applied infrared frequency is equal to natural frequency of vibration. So friend, absorptions of IR radiation takes place and peak is observed. Different functional groups observe characteristic frequency of IR radiation and gives the characteristic peak values. Therefore, IR spectrum of a chemical substance is a fingerprint of a molecule. Fingerprint of a molecule. Very important sentence. Fingerprint of a molecule for its identifications. So, criteria for a compound to absorb IR radiations. Correct wavelength of radiations. Change in dipole moment. Correct wavelength of radiation means a molecule to absorb IR radiation. The natural frequency of vibrations of some part of a molecule is the same as the frequency of incident radiation. My friend, change in dipole moment. A molecule can only absorb IR radiation when its absorptions cause a change in its electric dipoles. Friend, a molecule is said to have an electric dipole when there is a slight positive and slight negative charge on its component of atom. So, molecular vibration, there are two types of vibrations. Make your concept clear: stretching vibration and bending vibration. A lot of questions in JAM examination, NET examinations, and GATE examinations, and all national level examinations for different competitive exams. They have put some questions with IR spectroscopy. So make your concept clear. There are two types of vibration: stretching vibration and bending vibration. Stretching vibration, vibration or oscillations along the line of bond. Change in bond length occurs at higher energy. And two types: symmetrical stretching and asymmetrical stretching. Symmetrical stretching, two bonds increase or decrease in length simultaneously. I repeat, two bonds increase or decrease in length simultaneously. Asymmetrical stretching, in this, one bond length is increased and other is decreased. So, bending vibration, vibration or oscillation not along the line of bond. These are also called as deformation. In this, bond angle is altered, occurs at low energy. And again, two types: in plane bending, scissoring and rocking, and out plane bending, wagging and twisting. I repeat, again, bending vibration is two types: in plane bending, scissoring, rocking, and out plane bending, wagging and twisting. So, in plane bending, scissoring, this is and in plane bending, two atoms approach each other and bond angles are decreased. So, in rocking, movement of atoms takes place in same directions. So, my friends, I hope this video will be helpful to you. You can see here outer plane, again to wagging and twisting. Two atoms move to one side of the plane, they move up and down the plane. And twisting, one atom moves above the plane and another atom moves below the plane. So my friend, if you like this video, then subscribe my channel, and thanks for watching.